All right, guys, 7.3. We are doing more graphing, but I think you're going to like today. We're graphing circles, which is probably brand new, which sometimes makes you guys nervous. But the good news is graphing circles is very, very easy. It's not nearly as complicated as a lot of the other functions that we use. Now, in general, before we talk about the notes down below, a circle graph it's not actually a function, because remember, functions, if I draw a circle, a function, you're not supposed to be able to draw a line up and down that goes through it twice. That makes it not a function. So a circle is actually not a function. It's a combination of two functions. One of them is the top half of the circle, and the other is the bottom half of the circle. And when you combine them, you get the equation of a circle, which sounds really complicated, but it's actually a really easy equation. It looks something like you've got an x squared, you also have a y squared, and when you add those together, you get the radius of the circle squared. So this looks a lot like the Pythagorean theorem, which it is. The only difference is this is also the equation of a circle. Now, in this case, x squared plus y squared equals r squared. X and y are not being manipulated at all. So the center of the circle would be right at the center of the graph. And the radius is just the square root of whatever that number on the other side of the equal sign was. So if this said equaled 4, then we would have a radius of 2. So this would just be a circle with a radius of 2 right at the center of the graph. Now, obviously, that would get really boring. So we want to move the circle up, down, left, right. We want to make it bigger and smaller. And here's how we do that. Any number inside the parenthesis with the x is going to shift it left and right. Any number in the parenthesis with the y is going to shift it up and down. Now you've got to be careful, because notice it is both of these are being shifted in the opposite direction. So I'm going to draw an arrow from the h, and it's going to tell you this is the left and right shift in the opposite direction. Remember, that means if it's a +5, you are shifting your circle 5 to the left, not 5 to the right. Now, the number that's in there with the y, we call k, and that is also going in the opposite, but that's the up and down shift. So this is the up and down shift of your circle in the opposite direction. So unlike the other shapes that it didn't go in the opposite, because it's inside with the square, it does go in the opposite direction, okay? So that gives you your center of your circle. If you get h comma k, there's the center of your circle. And then r, whatever is on this side by itself, that gives you the radius of the circle. So if this number was 9, I would have a radius of 3. If this number was 25, I would have a radius of 5. Notice you have to square root that number to get the radius. And that's it, guys. That's circles. Now, again, I mentioned it. You've noticed that the Pythagorean theorem looks a lot like the equation of a circle, and that's not an accident at all. If you have a circle, and from the center, if I was looking for anywhere in this circle, I could go, let's see, I'm going to zoom in a little bit, and if this is my center right here, and I put a dot anywhere in the circle, I can go straight over to my dot, and I can go straight up to my radius. And what I've created is a right triangle, and this is A, this is B, this is C. So the Pythagorean theorem is very much connected to the formula of a circle because that's how you get the radius of the circle as well. So we want to identify the center and the radius of these circles. So when I look at example A, I've got x plus 7 squared. Remember, this is my left-right shift, but it goes in the opposite direction. So I'm going to go -7 to the left, and the one in there with the y is my up-down in the opposite direction. So I'm going to go 2 up. So I'm going to go 7 to the left, and I'm going to go 2 up. So that means that my center is -7, 2. And my radius is the square root of this number. Because remember, the formula 36 is the radius squared. So I've got to square root 36 to get my radius. Well, the square root of 36 is just 6. So my circle is centered at -7, 2. And if I wanted to graph that, do I have a spot here where we didn't give you enough space to graph these? If I were to graph that, I would go -7 to the left. Whoops, I want this down here. I would go 1, 2, 3, 4, 5, 6, 7. I would go up 2. That would be my center. Now, my radius is 6, so I would go 6 to the right and put a dot. I would go 6 down, 1, 2, 3, 4, put a dot. I would go up 6, 3, 4, 5, 6, put a dot. I would go to the left 6, 1, 2, 3, 4, 5, 6, and put a dot. And when I connect these dots, I don't want a square. That wasn't a very good circle, was it? When I connect these dots, I get my circle. All right, example B. When I look at my equation, I'm looking for what's inside with x. It's a -1, so that means my function is going to be shifted to the right 1. And my +9 tells me it's going to be shifted down 9. So my center is 1 to the right, down 9, which is -9. And my radius, I take 16. That's my radius squared, so I need to square root 16, and I get a radius of 4. All right, C. X has no number with it, so that means my function is not shifted to the left or the right. So my left and right is 0, but my function, there is a -10 in with the y, which means my function is going up 10. So this would be a +10 as my center. The radius is the square root of that number, so it would be 3. Example D, -4 means I'm shifting to the right 4. Nothing with the y means I'm not shifting up and down, so my center is 4, 0. The square root of 1 is 1, so it has a radius of 1. So this one goes over 1, 2, 3, 4. That's my center, and then it goes a 1 in each direction, and there's my circle. All right, now it wants me to write an equation if it gives me the center and the radius. This is really easy to do. This number goes with the x, this number goes with the y, but you have to go the opposite. So I would put x -5 squared plus y plus 8 squared equals 7 squared, which is 49. Okay, example F would be x plus 3 squared, because I do the opposite of -3, plus y plus 5 squared, because I do the opposite of -5, and my radius is 10. 10 squared equals 100. So this number would be 100. Okay, G, center is -11, 0. So with x, I get a +11. With y, there's no number, so it's just a regular y squared. and those equal the radius squared, which is 64. Now, h doesn't shift left and right at all, so it's just a regular x squared. It does shift down 1, or sorry, it shifts up 1, but I write it the opposite. So I write y minus 1 squared. And then 2.5 squared is going to be what? 2 times 2.5 is 5 plus another, so what, 6.25, I think. Correct me if I'm wrong later. I'll give you a bonus. All right, this circle. First of all, I need to know the center. It looks like the center of the circle is right there. So that means my center is -2, 1, and it looks like it has a radius of 1, 2. So my formula would be x plus 2 squared plus y minus 1 squared equals 4. Okay. Example J, here's my center. So my center is over 3 up 0, and I have a radius of 1. So I get x minus 3 squared plus no change in y, so I can just do regular y squared equals my radius squared, 1. Okay, homework time. Nothing harder than what you've seen, other than it does ask you for domain and range in a few places, and I think that's something that you guys can handle just fine. The difference here is your domain and range are going to stop. Both are going to stop. Neither one of them are going to go on infinitely because a circle always starts and stops in both directions. So keep that in mind. Come see me if you have any problems.